Particular video, I want to show you how to manipulate simple harmonic functions according to the different types of graph that could possibly be given to you. So here's my first example. Here you have frequency versus 1 over radical m. So in the y-axis you have frequency, in the horizontal axis it is a little funky, it's 1 over radical m. And this particular problem wants you to find the spring constant. So based on the information given, I see that I have f, I'm given m, I'm asked to find k. So the first function that comes to mind is the simple harmonic function for frequency, which is 1 over 2 pi times radical k over m. So make sure your function is right to begin with, otherwise you'll be wasting time. Okay. So ultimately, this particular question wants you to find k. So I'm just gonna go ahead and just do a little algebra just to get k by itself. So I notice here I can split the radical term into two, so it'll just be radical k over radical m, which is essentially the same as putting the whole entire fraction underneath the radical. Okay. Now I want to do this because again I'm asked to find k, so I need to go ahead and kind of isolate radical k, and then from there I can find k. So I just rewrote my function here. So you notice here in my second equal sign I have 1 over 2 pi times radical k over m, or excuse me, radical k over radical m. However, I just switch the placement of 2 pi and radical m because really you're just multiplying on the bottom. So in the denominator you can just switch the 2 pi and the radical m. Why? Because according to the graph it gives you in the horizontal axis 1 over radical m. So I want to be able to get something like that so I can pull information out from the graph. Okay. So again, the numerator is the same. 1 is on top, radical k is on top as well. Instead of saying 1 over 2 pi, I can say 1 over radical m, and then I can just move the 2 pi to the right because I'm just multiplying. Now I did that because once again the graph gives you 1 over radical m, right? So here you just have to be a little clever. I'm doing that because I can find f, and then the point on the graph gives me 1 over radical m. So really I'll be done soon here. So in order to get radical k by itself, I need to do a little algebra here. So the first thing I'm going to do is divide both sides by 1 over radical m. So you notice here in parentheses I kept the f frequency on the top, and then on the bottom it's the whole quantity of 1 over radical m, and I'm almost done. So to do that, I'm just going to go ahead and pick a dot on the graph. Here I'm just going to pick 2 and 4 in the horizontal axis. Go right 2, go up 4. That's a nice point right there. Okay, it intersects the corner nicely, and you can pick whatever point you want. Just hopefully just pick a point that makes sense. This graph seems like for every 2 over it goes up 2. Okay. So other than that, I'm just going to go ahead and plug values in that I know. Based on the dot that I've chosen, the y-axis is 4 and the horizontal axis is 2. So frequency being in the vertical axis, I replace that with the 4. And then 1 over radical m is 2 because based on the graph given. And then here, all I'm going to do is I'm just going to go ahead and combine like terms. 4 over 2 is 2. And then I'm just going to move the 2 pi up to the top left, or multiply both sides by 2 pi just to get radical k by itself. So that'll be 4 pi. Or you can say 4 times 2 pi is 8 pi, and then 8 pi divided by 2 is just 4 pi. However you want to do it, okay? But as you can see here, I don't have k by itself yet. This is radical k. So to get k by itself, you need to square both sides. So I'm going to go ahead and square both sides just to get rid of the radical symbols, just to get k by itself. And then 4 pi square. Make sure you use parentheses here, otherwise you are going to screw up at this particular junction, which you don't want to, right? You've done a lot of hard work. So other than that, if you put in parentheses 4 times pi, and then you're going to square that quantity, you'll get about 157.8 newtons per meter, and that is your answer for this first graph. Alright, so here goes the second one. Here's the second one. The second one gives you a frequency versus radical k graph, right? And it wants you to find the mass. So once again, I'm just going to kind of start with the same function here. I'm starting with this function because the vertical axis here is f, right? So why not start with the function that gives you a lot of the information already? So here, radical k is in the horizontal axis. I'm trying to find m, so I'm just going to go ahead and kind of use the same strategy here. I'm going to go ahead and break radical k over m into two terms. It'll be radical k over radical m, and then from there I can just go ahead and simplify the numerator. Well, 1 times radical k is just radical k. On the bottom it's just 2 pi times radical m. So really I'm just cleaning this up a little bit, and from there I can just go ahead and multiply both sides by radical m, because in this particular problem I'm trying to find m. So I should focus on getting radical m by itself. So I'm just going to do 2 steps in one here. to get radical m to the numerator, I will multiply both sides by radical m, and at the same time though, divide both sides by frequency. So really I'm just going to move radical m up to the top left. At the same time, I'm going to move frequency down to the bottom right, because here in this function I'm just multiplying and dividing. I'm not adding or subtracting, so I can do that quick switcheroo. Okay. So as you can see here, in this particular function, we're almost done. You have radical m, but then you have radical k on top, which can be extracted from the horizontal axis here, because the horizontal axis here gives you radical k, right? So we can kind of pick data out from the graph. Well, the vertical axis is f. So I highlighted radical k and f here because this particular graph gives us those two quantities. So I'm just going to pick a point. Once again, pick a point whatever you want. I see for this particular graph, the graph intersects nicely at x equal to 20 and then y is equal to 9. Or you can go to 40 and 18, right? So it seems like this particular graph goes 20 to the right, up 9, 20 to the right, up 9, okay? So I'm just going to plug and chug. Radical k here, I'm just going to plug in 20 because that's what it said so in the graph. Well, if I go radical k is 20, I go up to where it touches the slope, and I go left, and that's 9. Hence, frequency on the bottom is just 9. So it would be 20 divided by 2 pi times 9, because that's the information I can pull from the graph. So I'm just going to simplify the right side. So if you punch all this good stuff on your calculator, you get about 0.3537. But once again, the left side remains to be radical m. To get m by itself, square both sides. Squaring both sides, get rid of this radical. So that'll give you m. So if you punch all this wonderful stuff on your calculator, you should get a value of about 0.125 kilograms. Okay. So hopefully you've seen kind of how to manipulate this function so far in the first two graphs here, just to get what you want. Okay. So hopefully algebra skills on point. All right. Here's the last of the graphs in this particular video. So here, it says here you're given a frequency for a simple pendulum, aka like a bob on a string, right? And it wants you to find the acceleration due to gravity. So in the vertical axis, you have f. On the horizontal axis, you have 1 divided by the radical of the length of the pendulum. So I'm just going to go ahead and start with the function for a simple pendulum. The function for a simple pendulum here for frequency is 1 over 2 pi. Similar to a mass on a spring there, except it'll be gravity, acceleration due to gravity on whatever planet divided by the length of the string. So here, the length of the string in the graph here is just denoted as lowercase l, so I just kept that lowercase l. If it uses capital L, then you can just use capital L. It doesn't really matter, okay? It's just the length of the string regardless of whatever variables they use. So, same skill. Ultimately, we're asked to find g, the acceleration due to gravity. So I'm just going to go ahead and once again break up this radical into two terms just so I can do algebra. And from here, I can just go ahead and rearrange this function here. Once again, on the top, you have 1 times radical g, and on the bottom, you have 2 pi times radical L. However, I switched to 2 pi and the radical L again in this particular graph because I recognize that on the horizontal axis, excuse me, it's getting late at night here. This is 1 divided by radical L, right? So I'm switching that because I can get this term to look like the horizontal axis, 1 over radical L. F is in the vertical axis. So at this time, to get g by itself, or radical g by itself, I'm just going to go ahead and divide both sides by 1 over radical L. As you can see, now I can just put information f in the vertical axis and then information 1 over radical L here in the horizontal axis. So really, at this point, I'm just going to pick a point like I did in the last two graphs. Here, I'm just going to pick 3 and 5. It looks like a nice point. You can pick 6 and 10. You can pick 9 and 15 if you want. I'm just going to pick 3 and 5 just to keep the number small. So here, the frequency is just 3 because that's on the vertical axis. This point intersects at 5 and 3, right? 5 to the right, up 3. So f would be 3 because that's the rise. And 1 over radical L would be 5. So I'm just going to replace that whole parentheses with just 5. And on the right side, nothing has changed. But as you can see here, radical g is not by itself yet. So all I have to do is multiply both sides by 2 pi to get radical g by itself. And then, so it will be 6 pi because 3 times 2 pi is 6 pi divided by 5. And in here, I'm just going to square both sides. All right. So if you take your calculator and you punch in 6 pi divided by 5, you get 3.77. And then don't forget to use parentheses. You're going to square this. And other than that, 3.77 square is going to give you a value of about 14.2 meters per second square. And that is your answer for this particular graph. So ultimately here, the goal is just to play with these functions, you know, extract out what you're given in the graph, right? and then from there, hopefully just pick a data point and then plug in the values that are given to you. Okay, that's kind of the big picture here. All right, I hope that helps. Stay nerdy, don't be whack.